Hey everyone, welcome back. Now I'll show you guys the second program. I said it would take 2 days. It did take 2 days to make it, but this time I wanted to extend it and see where I could take the program and try to include more features into it. Therefore, it'd be easier to use in the future because I'm gonna use it again many times. So, what the program's supposed to do, let's start with that so you guys know why I decided to make this program. So one of the things the program should do is that it should open the files that we created last time. All those files that I created, well, they need to be analyzed further. So when I showed you guys the last program, it created these files, these FOOF results files. So in one patient right here, 2120, there's many of these FOOF result files. In this folder, subfolder, there's 1079 files. And about a third of them are FOOF results.mat. Those of them they have a lot of data for said patient that we extracted last time. That's the program I made last time. That's what it did. And it's about a third of them. And these are how many patients there are. So there's a ton of patients. And as you guys saw, that one had 1,000 files in there. This has 1,233. This one has 1,500. 7,000 is the one that we run. 2123 has about 2,000. So these patient numbers add up, as you can tell. So if I were to do this manually, I'm supposed to open up one file, click finish right here, let it generate, opens up in FOOF. I click FOOF right here, it goes here, it creates a struct for me. In this struct, I look at these values like, I need this value right here, this is a slope, this right here is the offset, these are peak parameters, but I need to open that and look at it, because there might be multiple. In this case, there's only one row, but usually there's 3 or 4. I need to note this frequency, and then I need to know these sub 2 parts for the said frequency so I can look at it further later on. Same with the error, same with the R squared, and I'm supposed to note all of this and put this in an Excel file. And then using that Excel file, I'm supposed to then graph the data. Maybe graph it like this. This is how my end result of my Python script is. It's graphing the slope values, the offset, the error, the peak frequencies, the frequency areas, the R squared, and the alpha and the beta area. This is for a certain set of frequencies. So this is for frequency from 13 to 39, something like that. This is from 8 to 39, and what the area was. So like you're looking at these and splitting them up, and this is just the peak frequency versus the area they had. So this is for ventral 5 millimeters. This is for ventral 4 millimeters. So you can look at different parts of the brain, the different millimeters from said part. This is just slope averages, how the slopes have been varying as you go down the brain. So stuff like that. And this is what I would be doing manually. I would click on this when this class opens up. Per patient, say track 0, I would take those values that I showed you guys and plot them and put them down like this, except these right here are averages. How do I extend this? Averages per millimeter, whereas what I was showing you guys earlier were 10-second segments. So a millimeter could be, say, 50 seconds long. That's how long we were in there, right? And then I need to grab those 5 sets and average them, and then put that as one value right here, and do this for the rest of these values. And then move on to the next patient and next patient and next patient. As you can already tell, that's very, very time consuming. And then say after I've done that, I'm supposed to compile all of those and then put an average list per millimeter and do this per millimeter, right? Graph this, showcase what happened, and even these, graph these, but now per millimeter. So I'd go to each file, grab it for the first millimeter, go to this one, grab it for the next millimeter, and put them together. And then using that, go on like insert plot and make those plots and use that for everything. So you can tell that it becomes, quite tedious, and already there's this many slopes that I'd have to make. So it looks like 11. There's 10 in here, and there's slopes So that's how many I'd have to make already, right? So if I open these up, I would have to make all these files manually after collecting the data. And yeah, I might have to collect the data differently because that happens a lot. You have to change your parameters a lot. As you can tell, that becomes already very tedious. So what I ended up doing was I created a program that does it for me. So let's just go there right now. Compared to last time, I am using a different program. I'm actually using Vim, which actually comes with your terminal. I decided to use Vim because I thought it'd be a better program to use. I just think it's nicer. if we think about this column, anything before auto figure up the way to foof is actually not part of this program. It's just other documents. But if you go down from brain section, console UI, and all the way down this column, those are all part of this program, and that's what the program needs at the back end. A lot of files are created just to separate stuff, and therefore not change every little component, because once it's done I don't really need to look at it again. So the main file that we look at actually is GUI.py. This right here is one of the files that creates the graphical user interface. So this doesn't take too long. This is one of the things I did at the very end, and it's very easy to make. And honestly, the only thing that really matters on this program right here is calling xdata. Xdata is the bigger file, and it's the one that calls everything. So this program is only 70 lines, and most of it's just repeat code, so you can make stuff like buttons and stuff. But once you know how to make a button and how to show text on it, it becomes very easy. But it can become a very powerful tool. Like right here, this is what the GUI I made using the GUI.py. It's only 70 lines of code and it does all this already. It also has that console output that you would get from running it on a terminal. So right here you can see all the values that I want to change if I want to run the program differently, like where the data path is, where all the data is contained. I can change that. I can change the R2 tolerance. The R2 tolerance indicates that if it's not 0.95, throw it away if it's less than this value, because then the data isn't good. This describes the histogram, the peak frequencies, the peak error that I showed you guys on the bottom left of the figure, like that was right around here. You can change how it looks and how the bins are made. It's called the histogram. And the points that are graphed in the scatter plot, how transparent they are. You might want to change that so your plot looks a bit different. So we can run this and it'll take about 30 seconds to run, but this is the back end of the program. This is what the program actually does. So while that's happening, I can show you guys the actual other program that we run. That could be a bit more about what the actual program is doing. So it's an xdata right here. So this stuff kind of outputs because of the MATLAB. I also have MATLAB outputting stuff to my terminal, but I didn't know how to get that MATLAB output into my own script. So I do have the output of the console that'll come up here by itself. But anyways, this is the back end of the GUI. This is where it's running most of its stuff. These are a lot of imports. The majority of them are my own files. As you can tell, from my own class, import this. And then these are a lot of the other stuff that we need, the other library imports that we need. So right here, you can tell that there's a lot of code. Majority of the code is just, setting up variables for later on. And this is the, peak array and stuff like that. This is the value, grabbing it from right here. It's just, grabbing those values, giving us the maximum millimeter to check. We said 5 millimeters because 6.7 didn't look good. It was very noisy data. So just defined it and hard coded it. I could probably put that in the GUI too right here, how many to do, and that's not hard to do. It's actually very, very easy to put into it. It's just the back end is the harder part to do, and this is the part that I got actually majority of it done in 2 days, but then I started rewriting a lot of it, splitting it into files and cleaning up the data. Here we're just grabbing trajectories, we're showing the trajectories, and here comes the main loop right here. It does a lot of function calls, defines brain section class, makes an object of it, and stores that data, grabs the data from the middle, stores it down here into a Excel file. This is an Excel file that I showed you guys earlier. It creates the figures and etc. and it grabs it again. This is different. This is a different grab. This is for grabbing it for if it was ran differently. So yeah. And this is just some print statements like saying loading figures, even though I took that line out where it actually loads the figures because it became a bit annoying to look at. But anyways, this is how the program runs, and once it runs it also gives you the time that it took. So this time it took 39 seconds. When my laptop was a bit cooler, as you can tell, like right now it's very loud. When it's cooler, it actually runs in 30 seconds, which is amazing. But anyways, this is the program that I wrote, and I said I would show you guys, and well, now I am. Oops, sorry, I need to be in here. I wanted to go. So that's some of the program, and I showed you guys earlier about all the other program lists. The cool thing about it is how I was stating that how I need to create those figures individually using a Excel, and how it could be annoying if we, maybe change the way we look at the data. Here it's pretty easy me changing. I just go to create figures and I change how the data is plotted right here. So and later down the road we want to look at the data a bit differently. I just change this Excel, not Excel, this Python file right here, and actually specifically this function, and not even the bottom part, maybe just this part. The majority of the time we're looking at average. So I do have one that doesn't look at average and plots non-average data. But here's the average data being plotted, and I could just change this right here, and I could change how the data looks. Super easy. And here it's data that doesn't get affected by the average, so I have to change this too. But here you can see how quickly I can change what I want to do. Whereas if I wanted an Excel file, I'd have to do it manually, and it could be very, very annoying. And I can't run the program many different ways, as it requires more stuff, and there's more error being allowed. Being me, where maybe I don't select the millimeter by accident, and other stuff like that, and I'd have to manually throw out data that wasn't above my threshold. Say it was 0.94, I have to manually look for that and manually throw it out. That could be very annoying, and it could be very easy to miss. So anyways, this is the program I want to show you guys. I will see you guys next time if I do create another one, but I think this might be it for all the research needs that I need to do, because by this point it already does that, and I'm at the analyzing point. Where I can actually analyze the data now after this point. So majority of what's left for my research is maybe converting a lot of analog data back to digital, and then running these scripts on it. And then writing a paper on it. But I'm already done the digital looking, so I can look at the digital parts very easily. Say around 30 patients will take me around total 40 minutes to run, and that should be about it. Whereas without my scripts, it could take me about up to a week and a half, or maybe even 2 for those 30 patients, because adding the plotting and stuff like this adds a lot of extra work. Now all the work that I do have left is actually just converting analog to digital and then running a script on it. 30 patients takes 40 minutes about, and that should be it. So yeah, by the end of the summer, or by the end of July, I should be done all the patients, and then I just need to write a paper on it. Anyways, it was nice telling you guys. These are the programs. If I do make other programs, maybe not related to my research directly, I would showcase those to you guys. Anyways, goodbye. Thanks for watching my video.